Hello, you are listening to Pankaj Rai, and in this video we will be discussing the numericals of interference of light. So let us begin. You must be knowing the condition for constructive interference, which states that when the two rays are meeting, then if the path difference between the two waves is equal to even multiple of lambda by 2, then that would be a constructive interference. That means there will be a bright band or a bright point. Algebraically, the even multiple is written as 2n, where in this case n could be 0, 1, 2, 3 and so on, where n is representing the nth bright band. 0 will be for the central bright band. Okay, now moving ahead with the condition for destructive interference, you must be knowing that destructive interference happens when the path difference between the two interfering waves is equal to odd multiple of lambda by 2. So the path difference is equals to 2m minus 1 into lambda by 2, where m is 1, 2, 3 and so on, where m is representing the number of dark band, the mth dark band. So this is the basic information which we need. Now there are few numericals asked on this theory. Let me take an example. Let's say that there are two sources S1 and S2 of light which are sending out coherent waves, and let's say there is a point P in the medium, and it has been given that the distance of point P from one of the source is let's say 6.5 centimeter, and distance of point P from another source is given as well. Let's say it is 6.65 centimeter. Okay, now the question is, what would be the point P? Would the point P be bright band or a dark band? So that's the question, the type of point P, and it has been given that the wavelength used is, let's say, 5000 angstrom unit. So this is the data we have been provided with. We have been given the distance of a point P from the two sources of the light, and just we have been given the wavelength of light. Now let us move ahead. Now the theory says that the point would be bright or dark depending on whether the path difference is even multiple of lambda by 2 or odd multiple of lambda by 2. But as of now we don't know what it would be. So let us assume that the path difference is some number, let's say p, a variable, into lambda by 2. Now I don't know what is this number, we have to find it. And if in case it happens out to be a even number, then we would know that it is a constructive interference, and if in case it happens out to be a odd number, then we would know that it is a destructive interference. So our objective is to find this variable where the path difference is this variable into lambda by 2. Okay, so we are having lambda here, the wavelength. What about the path difference? Path difference is the path difference between the two paths of source, from the two paths where the lights are meeting, or at point P from the two sources. So in this case the path difference is S2P minus S1P. So that would be the path difference is equal to, here we are saying, P into lambda by 2. Alright, let's move ahead. Now what about the path difference S2P? The path S2P is 6.65 centimeter minus 6.5 centimeter is equal to P into wavelength, which is 5000 angstrom unit, divided by 2. Now 6.65 centimeter minus 6.5 centimeter, that would be 0.15 centimeter, is equals to P into 5000 angstrom unit upon 2. Now let us convert it into standard units. So it is 0.15 into 10 raised to minus 2 meter. So that is a standard unit, equals to P into, this would be 5 into 10 raised to minus 7 meters upon 2. Okay, so our objective is to find P. So let us take each and everything over the left hand side. Alright, so here we will be having 0.15 into 10 raised to minus 2 multiplied by 2 and divided by, these 2 will come here, it is 5 into 10 raised to minus 7. The meter as well will come here and they will get cancelled. So we will be having a pure number. Okay, now what about this? So let's say this minus 7 will go up, it will become 7, and 7 minus 2 will be 5. So it will be 10 to the power 5. So let us give those 5 powers to this 0.15. So it would become 15000 into 2 the whole upon 5. So 5 and this 15, they will get cancelled in 3, and 3 into 2 will give us P as 6000. So we are getting the number P as 6000. Now what does that mean? Okay, what is P actually? P is the variable which we have taken here, that path difference is P multiple of lambda by 2. Now we know that if that number is even, which is even in this case 6000, so we know that it is a constructive interference. So we can write it as that path difference is P into lambda by 2. That's what we assumed, but now we are getting that path difference is 6000 into lambda by 2, but P is coming out to be even. So this is being matched with the equation of constructive interference, which states that there will be constructive interference if the path difference is even multiple of lambda by 2, where the path difference would be 2n lambda by 2. So we know that it is a bright band. We are just moving ahead to find out which bright band is it. Now as you can see that this P, the 6000, this even, and this 2n, they are one and the same. So I can equate that 2n is equal to P. So we are getting that 2n is equal to 6000. So n will come out to be 3000. So as we have already discussed that path difference is even multiple of lambda by 2, that is 2n lambda by 2. The number here came out to be even, the 6000, and the n here represents the number of bright band. So we know that this P will be the 3000th bright band. So in this way you can find out the type of band which would be formed if you have been given the path difference, or you have been given the distance of the point from the two sources. Thank you very much.